Some graphs have symmetry on a coordinate grid. All right, so for this first one, guys, the graph of a relation is symmetric with respect to the x-axis if and only if you replace y with negative y and you get the same input. So this is symmetric to the x-axis. Here's a point up here. This is equidistant to the x-axis from the point below it. What you must realize is that it's not an equation. I'm sorry, it's not a function. I have two x values with different y coordinates. I have the same x value with a different y coordinate. Also, guys, we are replacing an output with a different output. That is not how you analyze functions. So this is not a function ever. No, no, no. All right, let's look at this column. The graph of a relation is symmetric with respect to the y-axis if and only if for every point xy on the graph, the point negative xy is also on the graph. What this means, guys, look at this column. I'm going to start here. We're going to replace the original input with the exact opposite input. If we end up with the same output, it is symmetrical about the y-axis. Look over there in green by that awesome OU helmet. That is also an even function. Look at the even function. If I plug in a negative x, I'm going to get the same exact y coordinate right there, guys. So please write this as an even function. We talked about that a little bit last week. If you plug in the opposite input, you're going to get the same exact output. Last one. If I take my original input and replace it with the exact opposite, and my original output turns into the exact opposite, then it's symmetrical about the origin, which is also odd, which is over there in green, guys. So this is odd. This is like half your quiz. This is half your test. You are not given this graphic. Make sure you understand this. This one isn't too tough to remember, y'all, because of all the letter O's. Remember, it is an odd function. If it is symmetrical around the origin, I know it's symmetrical around the origin if my output, there's another O, is opposite. All those O's are going to tell you it's odd, symmetrical about the origin, an odd function, all of that. Outputs are opposite. So those are all attributes for the functions that we're going to talk about today. We are going to look at these two. We have one more attribute to talk about tomorrow. All right, look, y'all. Let's look at problem number 5. Problem number 5 is symmetrical to the x-axis. That distance is equal. Those are two equal. Is that a function? Would that pass the vertical line test? No. Y'all, look at the exponent on y. On the equation, remember, if you have an equation and it's raised to an even power for a y, it is not a function because you have the same x coordinate with different y coordinates. So this is symmetrical. I'm just going to abbreviate. Symmetrical to x-axis. Number 6. Number 6 has branches like that where they appear like in different quadrants and stuff when there's a break. And when it comes to branches, I don't really trust the graph. So I'm going to make a T-chart, but this is ugly to me. I'm used to y being by itself. So I'm going to divide both sides by x. So guys, I'm just going to have a little input-output table and analyze it from there. I'll just write it right here. Let's plug in a positive 2. When I plug in a positive 2 right there, what's a positive 4 divided by a positive 2? Yeah, that's going to be the output. Good job. Let's plug in the opposite. What's the opposite of positive 2? Negative 2. Okay, what's 4 divided by negative 2? Negative 2. You got your opposite output, so we know it is symmetrical to the origin. And that's how you're going to test that stuff.